All right. So good evening, Babu. Good evening, Bala Subramaniam. Good evening, Kamal Raj. Good evening, Lakshman. Good evening, Prabhu. Good evening, Rakesh. Good evening, Reshma. Good evening, Senthil Kumar. Good evening, Sri Krishna. All right, so let me quickly introduce about myself. Myself is Shukla, and I have close to 10 years of experience, mostly into databases. And from past 4 years, I'm working on big data technology, like Hadoop and then NoSQL databases. I have very good exposure about MongoDB, development, administration, designing, and lots more related with that. So this is brief introduction. I would request everyone to quickly introduce about themselves in just 1 or 2 sentences so that we can know each other. It will be great if you could write your years of experience and background in 1 or 2 sentences. All right, so Bala Subramaniam, he is saying he's from Chennai and he's working in private concern. All right, great. Okay. All right, so Sri Krishna, he is saying he's from Bangalore and he's having close to 9 years of experience in test automation. Welcome to the webinar, Sri Krishna. Hi, Kamal Raj. All right, so Rakesh is saying he is from Mauritius and he's working as educator teaching chemistry. He holds degree in chemistry and degree in business informatics too. Great. Welcome to the webinar, Rakesh. All right, so Kamal Raj is working in Emphasis. He is having close to 3 years experience. Welcome to the class or webinar, Kamal Raj. Reshma is working as a senior software engineer in a private software company and having 3 years of experience. Great. Welcome to the class, Reshma. Sorry, welcome to the webinar. Prabhu is having close to 8 years of experience and he is from Bangalore. Welcome to the webinar, Prabhu. Lakshman, he is saying he is from Bangalore and he is an entrepreneur. Welcome to the webinar, Lakshman. All right, so we'll wait for a few minutes so that all others can come on board, and then quickly we'll get started. So just we'll wait for 2-3 minutes, and then quickly we'll get started. So Bala Subramaniam is asking, is there video webinar now or only audio? So Bala Subramaniam, this will be audio. All right. So Reshma is asking, is laptop is required for this webinar. So Reshma, it's not required. If you have anything where you can see my screen, even you can display over your tab or phone itself. All right, so let's start now. Yeah, so you can use that. Great. All right, so let me explain about webinar, which is on MongoDB. So in this webinar, we will understand, overview of MongoDB, or you can say introduction about MongoDB. So these are a few topics which we will be learning throughout this webinar. So the first is why there is need of NoSQL database or databases. Then benefits of NoSQL over RDBMS. Third will be, we will compare NoSQL with SQL databases, or we can say RDBMS databases. Also, we will learn how MongoDB solves the problem. Then some use cases of MongoDB, and last we will learn about, or we will understand about job opportunity and trends about MongoDB in the market, as well as in our business, I can say here. So these things we are going to cover throughout this webinar. So let's understand about database category first, and then we'll go to the MongoDB. So at high level, we can see here there are 3 categories of databases are there. First one is RDBMS, OLTP or real time. Then second one is DSS, OLAP, DW, and the third, or you can say latest or new category, is NoSQL, NewSQL, or big data databases. All right, so let's understand about OLTP. What is that? Or RDBMS, or we can say real time. So OLTP means online transactional processing system. And what happens in day-to-day activities if you go to any mall or shopping complex or anywhere, or if you go to bank or if you go to ATM, you do some transaction, right? So that transaction will be updated in your database right away, which is called real-time databases, right? And lots of different kind of DBMS softwares are there, and vendors as well. So you could see here Oracle, MySQL, MS SQL, DB2, and lots more, vendors are there. All kind of DBMS softwares are there. So now, why this guy came into the picture? DSS or OLAP or DW. So DSS means Decision Support System. OLAP means Online Analytical Processing System, or DW. So all is same. Either you can say DSS, OLAP, or DW. So why there was need of data warehouse system or DSS or DW system? So let's understand about this OLTP again. So as I said, whatever transaction you perform, right away it gets updated to the real-time system, which is called RDBMS. So now let's say if 1,000 transactions are happening per second, or just assume some 300, 400 or 500 transactions are happening per second. Now, if you wanted to perform some reporting or analytical activity on this OLTP, that will slow down your performance, because already applications or transactions are happening on real-time basis, and if you wanted to perform some kind of reporting or analysis or analytical activity on RDBMS, this will slow down your performance. So then there was need of another kind of system, which is called DSS, OLAP, or DW, or data warehouse system. So what we do, we transfer data from here in batch processing or after certain interval, and then we push it here in DSS or OLAP system. So what benefit we derive? So if you wanted to perform any kind of analytical reporting or decision making, some use cases out of this database, so there won't be overburden on this real-time system or OLTP system, because you have migrated data on this system, and then we can, or you can, or we can perform analytical activity on DW system or OLAP or DSS system. So this is the benefit, or this was the requirement why this OLAP system or DW system came into the picture. Another could be, let's say here OLTP system, one OLTP system is on Oracle, second one is on different DBMS software, third one is on different DBMS software. So to have a centralized mechanism, you extract data and push it at DW or data warehouse system. Is this clear, guys? Why there was need of OLAP system? All right, so Rakesh confirms, Sri Krishna also confirmed. What about others? Sure, Balasubramaniam is having question. Please go ahead. Please ask your question, Subramaniam. You can write your question there. Okay, Bala Subramaniam is asking, is there OLAP similar to online system application? So online system application could be similar or it could be same. So moreover, as I said, we perform analytical activity or reporting activity. So either you can custom build your application or you can use ready-made application. For example, I can use here Tableau, I can use here ClickView, I can use here Jaspersoft, I can use here Pentaho. Lots many tools are there for reporting. We can use SAS, we can use here SPSS, we can use here various analytical tool as well. Did I answer your question, Balasubramanian? Alright, so Rakesh is saying to remove the burden from RDBMS which suffer if we make analysis right. Absolutely right, Rakesh. That's what I was trying to explain here. Great. Now we are clear. To reduce burden from OLTP, we realize there should be some different kind of system, and then we came up with DW, right? Also, there will be lots of changes, in terms of architecture and kind of software. In OLTP or OLAP, you could see here OLTP are normalized, OLAP are denormalized databases, and so on. Nowadays, the growth of data, the kind of data is completely different. It has changed the complete flow, I can say. So again, this OLAP system is not capable to handle those kind of scenarios. That's the reason NoSQL or NewSQL or big data solutions came into the picture. So this is also called next generation databases or NewSQL or NoSQL. There are again various kind of NoSQL databases are there. We will learn quick in upcoming slides here. All right, so we have again question. All right, so Rakesh is asking in what way the OLAP cannot handle the data. All right, so in terms of, so I will show you what all the scenarios where this OLAP won't be able to handle, but at high level, let's take example of unstructured data, polynomial data. Those kind of data is difficult to handle by OLAP, as well as, let's say, if your volume of data is very huge, if we say in petabytes, so this kind of databases are not capable to handle, as well as these are very, very costly. So we will learn in upcoming slides. Did I answer your question, Rakesh? All right, so there is a question from Balasubramanian. He is saying, how come backend databases support in OLAP in future generation without main data written? Yes, you are right, Balasubramanian. So I never said we are going to remove that. I said there will be another kind of database which is being used in different use cases. I never said if OLAP came, we remove this OLTP. Again, I am not saying if this guy came, we are going to remove OLTP or OLAP. But this in most of the cases, this guy is getting removed here. Clear? Yeah, Rajendra is saying license of RDBMS will be very high. Yes, Rajendra, you are very much right. So by the way, I'm going to explain each and every points here. All right, guys. So now we understood why NoSQL came into the picture. So let me go here and explain a few more points. So what all challenges are there with traditional databases? If we say traditional databases, so traditional databases you could say, RDBMS or, this OLAP system. This is also based on relational database, right? So relational databases are not really good for huge data. If we are saying huge data, in the sense we are talking about petabytes, gigabytes, and so on. Also, RDBMS systems are not much more capable to handle unstructured polynomial data like image, video, text, etc. So there are workaround way to manage, but there is no native supports for those so huge of data and different kind of data. So that's the reason NoSQL came into the picture. Here is an example, in Aadhaar card project, there are close to 15 to 20 petabyte data is there. So think if you wanted to retrieve any information, it will be very much difficult if you are using traditional systems. Then apart from that, a scale up. So what is a scale up, guys? For example, let us say if you have one server and after 1 year your data got increased twice whatever you have right now. For example, let's say currently you have 100 terabyte and next year data got generated again 100 terabyte in just 1 year, right? So in those cases you have to increase capacity of your server. Are you agree with that, guys? You have to increase capacity of your server. So how do you do that? To increase capacity of your server, you add more CPU, you add more RAM, and so on. But still there will be limitations, still there will be bottleneck to your server. After a certain interval, you won't be able to scale up. Are you agree with this point? Great. So that is another bottleneck with traditional systems or traditional databases. Those databases runs on servers and so on. But if you talk about the NoSQL databases, they can scale out, or you can say there is something called horizontal scalability. Horizontal scalability in the sense you can add more and more machine to get more power as well as storage space. So in terms of processing as well as storage, just you need to add more and more machines, you can achieve as much as you want. So that's how we scale horizontally. All right. Let me come here, it will become more clear. So this is summarized view, what all challenges comes along with traditional databases. If we talk about the data types, so nowadays, unstructured, semi-structured, or polymorphic data are more, which is difficult to manage by RDBMS systems. That's the reason, NoSQL database came into the picture. Agile development. So what happens? People does not want to wait for anything. They want to develop, then right away they wanted to push it to testing and then production. They don't want to wait for anything. Now let's think about the traditional system. For example, you are working as a developer. Now you are developing some application. So if you wanted to do any changes, you have to perform changes in database. Then only your application will work. Am I right, guys? Are you agree with this? To perform any changes in application, So for example, let's say if your application is getting interacted with some databases. Now if you want to do any changes in application, you have to perform changes in database. So think there is dependency and it is not agile development because you have dependency, and until and unless somebody will take care from database, you won't be able to develop your application. Alright guys. So but here if we talk about NoSQL databases, this provide a schema-less architecture. So what happens? You don't have to worry about database. You will, whatever you wanted to create through application, you can push it directly. It will be taken care by, your database. If I take your example, MongoDB, you don't have to worry about anything. Just you write code in your application and push data whatever, however you want. Automatically, it will be stored inside the MongoDB. So that's the beauty of it, and that's how you increase your development, a short development cycle. You reduce your development time. Volume of data. If you talk about petabytes of data or trillions of records or millions of queries per second, so in those kind of scenarios, RDBMS systems cannot work well. That's the reason again you have to have different kind of system, which is called NoSQL database. New architectures. So what new architectures? Just before some time we understood about horizontal scaling, commodity servers, and cloud computing. So as we discuss about vertical scaling, I can say, right? Here we discuss about a scale up. This scale up is also called vertical scaling. So in vertical scaling, what we do is on a same machine or single machine, we increase CPU and RAM, and then we try to get performance out of that, which is having certain limitations. But if we talk about horizontal scaling, what we have to do is just we have to add more and more machine to add more processing power as well as storage space. Also, we can use here commodity servers, commodity hardwares instead of expensive hardware. So if we talk about the server class machines, you would be knowing they are very, very costly, right? But if we talk about the commodity servers, they are very cheap and easily we can buy it. Is this clear, guys? Horizontal scaling, commodity servers, and so on. All right, so kindly confirm, guys, if you have any question, I can try to explain. All right, great. So there is a question from Rakesh. He is saying to give example of polymorphic data. So wherever there is relationship between, for example, let's take example of parent and child relationship. So if those kind of data is there, then that could be example of polymorphic data. Clear? Did I answer your question, Rakesh? For example, you can, let's take example. If I am saying there is a product, inside that product, sub-product, inside that sub-product, and so on, right? If some hierarchy kind of thing is there, so those kind of data you can consider as a polymorphic data. So I hope we are clear till this point and we understood what all challenges are there with traditional databases. Any question here or anything? All right, so Bala Subramaniam has asked question. Okay, I didn't get your question, Bala Subramaniam. Can I unmute you? Would you like to explain your question? All right, so let me unmute you. Yeah, please go ahead. Yeah, Bala Subramaniam, I have unmuted you. Bala Subramaniam, I have unmuted you. You can tell me your question right away. You can speak, we can hear you. Am I audible, guys? Because, okay, he is not having headset. No problem. Okay, let me try to understand your question here. Still, I am not getting your question. You have written, I am entering a DB where many data is stored in shorter form. How to develop in MongoDB? I'm not able to understand, Balasubramaniam. Could you club your all lines in a single sentence and then? All right, Kamal Raj is asking to give example of real-time examples. Sorry, a real-time example for commodity server and cloud. Yes, I will give you Kamal Raj. So just I'm trying to understand question of Bala Subramaniam. He asked twice that question, but somehow I'm not able to understand because he's okay. Now he has written in single. There is a question from Balasubramaniam. He is saying, if a single data is entered in generic data form of billions of bits where my structure is not same. If a single data is entered in generic data form of billions of bits where my structure is not same. All right, guys, I'm sending this question to everyone. If anyone who can understand this somehow, I don't know, I'm not able to understand. I thought I will unmute and then he can. Okay, all right. So, Balasubramaniam, what I can do is just you write your question in email, okay, and I will try to answer your question because somehow, I mean, it's not clear to me, your question. So, all right. So, there is another question from, all right. So, my email ID is narendra@edureka.co. Another question is there from Rakesh is saying, can we use MongoDB just like MySQL database? Yes, you can use that. There are two kind of version. One is community and second one is enterprise edition. So community edition is free, anyone can use without any license or without any licensing cost. All right. So Bala Subramaniam is asking difference between MongoDB and RDBMS. So we are coming to that point. So all right, guys. So these are some uh, you know, fundamental differences where sorry, there are some challenges with RDBMS system, and that's the reason new kind of database was required, which is called uh, NoSQL database. So, all right. So Rakesh was asking to give some example about, commodity servers and cloud computings. So if we are saying commodity servers, commodity in the sense normal or general kind of machines, whatever we use. So for example, probably you can say quad core processor of 16 GB RAM is called commodity hardwares or commodity servers. Did I answer your question? All right. So now let's understand one quick real-time example. Here you could see just I have pasted one picture which shows, if we try to find out flights, from one place to another place. So, I mean, this is example of any application. So here I am showing, let's say 5,000 transactions are happening per second. And here you could see, how we design, or we can design in, if we are using RDBMS system here. So to perform this kind of activity, you should have one caching layer. Because if transactions are more, then it will be quite difficult for RDBMS system to handle those kind of requests. So you should have one caching layer to handle those many requests at the same time. So if you will use here NoSQL databases, there is no need of using this caching layer. You could see here it is capable to handle 1,000 transactions per second, and you can get the same kind of result at your end. All right, so there is another question. Sri Krishna is saying, are you talking about queues here, like MQ? Not exactly a queue, it's a caching layer which you can use. There you can use some other kind of system there. All right, so here we can use NoSQL databases. Let me go back to the previous slide. Here we have used caching layer, but if we use NoSQL, there is no need of caching layer. So those are some fundamental problems which was there with RDBMS, and that's the reason NoSQL database came into the picture. So there are some beautiful advantage of NoSQL. So a scale out shared nothing architecture capable of running on large number of nodes. So let's say if you need a more processing power or more storage, what you can do is you can add one more node, or you can add one more machine. And it is having capability to handle, lots more number of transactions per second. It provides you a schema-less data model. What does that mean, schema-less data model? So as I gave example, for example, let's say if you wanted to develop your application without bothering about the database, so there should be some provision. If you are pushing anything from your application, database should be able to handle it. which does not happen in RDBMS. For example, let's say if you wanted to change anything in your application, first you have to change in your database, then only it will be able to interact, or it will be able to push your data in database. And these are designed for most query and few updates. So we will discuss in detail in next upcoming slides here. Alright, so there is a very good concept which is called CAP theorem, and it was been given by Bruce. So why there is need of, alright, so I think there is a question from Balasubramanian. Alright, he wanted to see the previous slide. Alright, let me go back. Yeah. Balasubramaniam, I hope you will get this slide, so no issue, there is no need of writing it down. Alright, so there is a question from Reshma. Is there no RDBMS concept in NoSQL? Yes, the concepts are a little different than RDBMS. Probably after the session, the support team will send this. Alright. So, let's understand about CAP theorem. What is that, and why we should learn CAP theorem, or why we should understand CAP theorem. So, before learning any distributed system, it could be NoSQL, it could be any kind of distributed system, we should learn CAP theorem. So if we are talking about NoSQL databases, these are distributed databases. So before learning about NoSQL or MongoDB, first we should understand CAP theorem, what it says, and what all terminologies are there behind it. Alright. So CAP, it indicates C, consistency, A is availability, and P is partition tolerance. So consistency, this means that the data in database remains consistent after the execution of an operation. For example, let's say if you are updating some fields or something, it should be consistent. It should be visible to all clients or all users. For example, let's say 5 users are there, Ram, Mohan, Sohan, and Shyam. If Shyam has updated, even Mohan should see the same data. That's what is called consistency. So this is consistency now. Again, we got questions from Leela. Viewer need not to write, they can simply take snapshot of the screen shared on the presentation by clicking on camera image on the top right of the screen. Please inform. Alright guys, so you can take snapshot also. Great. Balasubramaniam is saying, when the pronunciation of NoSQL is NoSQL. Yeah, you can say NoSQL or new SQL or not only SQL also. Alright, so now we understood what is consistency. Let's understand about availability. So this means that the system is always on. No downtime. So for example, let's say if you have only one server, for example, let's say you have installed any RDBMS software on one machine. If that goes down, right, so there will be downtime. You have to recover with some other, with some way, and then it will be available. So what CAP theorem says is the system should be always on, in the sense there should not be any downtime. So this is A. C is consistency, A is availability, and P is partition tolerance. So what it says is, this means that the system continues to function even the communication among the server is unreliable. So what does that mean? For example, let's say if you have 10 machine cluster, right? If one machine is down, even though you should be able to access your data, right? So this is called partition tolerance. Are we clear what is meaning of CAP theorem? What is CAP theorem? Why we should learn CAP theorem before learning any distributed system? And what is meaning of C, A and P in CAP? Yeah, go ahead with your doubt, Balasubramanian. I would request quick confirmation, guys. If you have any question, you can ask. Yeah, Vimal, you can ask your question. Balasubramanian is saying, is CAP theorem based on database server alone? That is not database server alone. That is for any kind of distributed system. All right, so there is a question from Senthil. He is saying, is this CAP theorem different from Bayes theorem? Yes, you are right, Senthil. It is different from Bayes theorem. Bayes is not a theorem. Actually, Bayes is just like acid. Acid property we say, right? So Bayes, you can say Bayes property. It's not a theorem. All right, so there is good feedback from Rajan. He is saying to continue so that we can cover more than main subject. All right, so let me cover this up and then later on we can have questions. So now we understood about CAP theorem. So what CAP theorem says, theoretically you cannot achieve all these three. You cannot. So let's say if you are developing or designing any distributed system at the same time, you cannot achieve all these three at the same time: consistency, availability and partition tolerance. So somewhere you have to compromise. So two you can achieve at the same time, and for third one you have to compromise. So for example, let us see in this Venn diagram here. This is consistency, this is availability, and this is partition tolerance. So all systems falls in different categories. You could see here MongoDB, HBase, Redis falls under consistency and partition tolerance. Here availability and partition tolerance you could see here. So CosDB, Cassandra, Dynamo, ReactDB falls under availability and partition. RDBMS falls under consistency and availability here. So RDBMS, this is also called single site cluster. Therefore all nodes are always in contact. When a partition occurs, the system blocks. If we talk about the CP, so some data may not be accessible, but the rest is still consistent and accurate. And AP is nothing but system is still available under partitioning, but some of the data returned may be inaccurate. So at high level, you can achieve 2 out of 3 in combination of CAP. Now, what is Bayes theorem? So it's not a theorem, Bayes property we can say. We know about ACID, right? ACID is relational property, relational database property, RDBMS system property. ACID, atomicity, consistency, isolation, and durability, which is called ACID completely. So NoSQL databases does not follow ACID property. It follows Bayes. All right, so there is a question from Paul. He's saying, why not all three are possible? Okay, so Paul is saying, does that mean in MongoDB my data may not always be available? So Paul, there is a way to tune it, whatever you wanted to achieve. Here, theorem says you cannot achieve all three at the same time, but you can achieve. So let's say if you wanted to compromise one out of it, you can do that. Did I answer your question, Paul? Okay, all right. So you can tune. If you wanted to achieve, you can tune according to your need. Okay, another question from Leela. What is the reason why 3 cannot be achieved? These are trade-off, Leela. All three together is not possible, Paul. If you will try to achieve all three, it is not possible. These are trade-offs. So let's quickly understand about Bayes theorem here. As I said, for RDBMS, it follows ACID property. For NoSQL databases, it follows Bayes. So what is Bayes? BA, basically available. S is for soft state, and E is for eventual consistency. So, all right. So another question is there from Rakesh. Rakesh, I mean, there is no mathematical. There are some, we can get into that, but let's first finish our course agenda, and then if time permits, we can discuss at the end of this webinar. So basically available, what it says, it indicates that system does guarantee availability in terms of CAP theorem. So for example, let's say if one machine goes down, another machine should take charge, and that machine should serve requests from clients. Soft state, what it says, it indicates that the state of the system may change over time. So may change over time even without input. This is because of eventual consistency model. So what happens, let's say if you have 10 machines, so how exactly the update or writing data to your cluster will happen? At the same time, for example, let's say if you have 1,000 machines, at the same time you cannot write information to all machines. There should be some mechanism, right, that first data will be written here, and then from here it will be applied there, and so on. So what it says, the state of system may change over time. So that's why the state of the system changes over time, even without inputs. Because for example, let's say if you have 10 node machine, one machine got updated, that is primary. So it will take some time to update on the other machine or secondary machines. So even though you are not giving input, the state of other machine will change over time. That's what is called soft state. Eventual consistency, what it says, it indicates that the system will become consistent over time, given that system does not receive input. So for example, let's say if you have given write operations to your cluster, it has been updated to the primary or one node where you're supposed to perform write. Then it takes some time to update on other machines, right? There will be some interval if your cluster is big. So eventual consistency says that the cluster or the system will become consistent over time if it does not receive input. So one machine is written, and if it is not getting other inputs, so the other machines will be written and it will become consistent over time if it is not receiving any input. So that's what is called base property here. Alright, so there is a question from Paul. He is saying, if it's basically available, what is not guaranteed here? So it is saying basically available indicates that the system does guarantee availability in terms of CAP theorem. So it provides guarantee, Paul. I mean, these are property like acid. If we talk about acid, A is for atomicity, C is consistency, I is isolation, and D is durability. So these are property. We don't do anything with this. Actually, we realize or we feel. Just like acid. If we are saying acid in the sense that records should be atomic. If we are talking about consistency, in the sense once you have updated the data, it should be visible with other clients or other users. The same way, these are property. Is that clear, Paul? Yeah. All right. Apart from that, there are more than 150 NoSQL databases are available, and different kind of databases is there. So at high level, there are 4 categories of NoSQL databases. First, you can say key value database. Second one, document. Third one, columnar or white column store. Fourth one is GraphDB. So here you could see, document database, and this webinar is mainly related with NoSQL and MongoDB introduction. So let me highlight here, MongoDB falls under this document data store. So as I said, NoSQL databases is having, there are 4 kind of NoSQL database: key value, document oriented database, column or white column store database, and graph databases. So each category is having different kind of use cases, and they are having their own strength and weakness. So while choosing any databases, as I said, there are more than 150 NoSQL databases, and then there are 4 categories. So it's very difficult and tricky part to select the right database as well as right model. Clear, guys? So for document database, you can see example like CouchDB, MongoDB, Couchbase, and lots more. For key value, you can see example Amazon, Redis, Memcached, and so on. For columnar database or white column store, HBase, Cassandra are example of that. For graph database, graph NoSQL databases, InfoGrid is there, Infinite Graph is there, Neo4j is there, Oracle NoSQL is there, and lots more. All right, so we have question again from Bala Subramaniam. Yes, Bala Subramaniam, So there is a question from Balasubramaniam. He is asking, MongoDB many data can be stored. You can store many data, much more data, any kind of data like video, image, structure, unstructured, polynomial data, and so on. Rakesh is asking question, which type to choose depend on our business rules. Yes, you are right, Rakesh, and also you should understand about tools and technology. Tools in the sense here, which NoSQL databases and then which category. So let's say, as I said, there are 4 categories here: document, key value, graph, and columnar. So which one you should go with? So this is very tricky part. So you should have understanding about all these 4 categories in depth, and then about your business in the sense your use case, and then you can select the right model. So let us see here what all pros and cons is there with different kind of NoSQL databases. So here you could see. Alright, so there is question from Prabhu. He is saying to explain in brief about key value pairs, column oriented DB and document oriented DB. Alright, so let me quickly go back and explain here. So by the way, if you talk about the document oriented database here, MongoDB, CouchDB falls under this. They stores data in JSON format. And again, they stores in the form of key value. So and they will use JSON format here. So I think we have very less time. It will be quite difficult for me to answer all questions. But what I can do is, probably you can already I have shared my email. You can drop an email along with your questions, and as soon as I can get your email, I will try to answer your questions. So before doing that, let us understand more than getting into depth here. So, and then if time permits, I will try to answer all your questions. So here you could see, this is requirement, then this is RDBMS, MongoDB, key value pair, and white column. If we are saying here MongoDB, it is document-oriented database. You could put here document-oriented database. Here I have written MongoDB just because we are learning MongoDB. So hierarchical data structure. This is very, very important slide, guys. You could get various information out of this in real-time scenario, and you can have very good understanding where to use and where to not use. So you could see here hierarchical data structure. I have written RDBMS is poor, MongoDB is great, key value pair is again poor, and then white column is good. Why we have given here MongoDB is great? Because it is having native support to hierarchical data structure. So for example, let's say, as I said, parent-child relationship. For example, let's say I wanted to store data like this. Country will be a field, then inside country, all list of countries will be there, and then for example, let's say India, US, China, Pakistan, and so on. Inside India, you will have various states, let's say Karnataka, Andhra Pradesh, Uttar Pradesh, Bihar, and so on. Inside each state, you will have district. Inside district, you will have, cities and so on, and then village, and then people names. So if you wanted to store that kind of data, so in RDBMS, you have to store data in various tables, and while writing, you have to perform join, which is very, very expensive. But in MongoDB, you will have hierarchical data structures. So in a single query, you don't have to join tables at all or collections here in terms of MongoDB. In one query, you can fetch all your information here. So that's the reason we have given here great. And dynamic schema. So if you wanted to change anything in your application, you have to perform changes in your database. But here you could see right away you can push your data and automatically MongoDB will store data, which is called dynamic schema. You don't have to go back to database and change a structure and so on. It provides native support for object-oriented programming. If we talk about the scaling, this supports vertical scaling, which is a really not good idea for a huge amount of data. So here I have given you a great. If we talk about the performance, you can realize, just use MongoDB install and use it, you will see that. Software cost, the cost of RDBMS softwares are really very, very high, but MongoDB is very cheap. Even subscription comes like $5,000 per year if we are talking about enterprise edition. If you wanted to use community edition, that is free. Data consistency, that's great here in RDBMS, no doubt. It is good, not as compared to RDBMS. Rich querying, it's great in RDBMS, here it is good. Ease of use, if you see, quickly you can learn MongoDB, even though if you don't have a very good background about databases. So that's the reason MongoDB is very, very popular nowadays. Yes, Rakesh, you can save object right away. There is question from Prabhu, a small difference, key value pair and key value. Key value pairs, I mean, both are same, key and then there will be value. Key value pairs, I mean, there will be a key and then value, then key, then value, and so on. So Bala Subramaniam is asking, if a duplicate data is entered, how can I delete it in MongoDB? So Bala Subramaniam, that is not part of this seminar, but there is a way to do that. Now let's understand about scalability, performance, and then depth of functionality. If we compare with RDBMS, you could see here, MongoDB falls here. So what it means is MongoDB tries to, provide a scalability and performance as well as depth in functionality. So you could see here, key value stores are very, very fast, or in terms of performance, they are very good, but they don't have functionality. I mean, they have very less functionality. Same thing is there with white columns. They are very good in performance, but very less functionality. If you could see RDBMS, these are having very good depth functionality, but not good in terms of performance as compared with other systems. Now, as I said, it's very, very difficult to or tricky part to select our right database or right model here. Here you could see, for example, let's say if you have to select any NoSQL database for your use case. So first thing you should understand is the right data model. Then also you have to keep in mind about pros and cons of consistency. Then compromising features of RDBMS. Here you could see, the features with RDBMS are very good compared to any other systems. Let's quickly compare with SQL databases and NoSQL here. So if we talk about the type, SQL databases, almost these are same. There will be little changes. For example, let's say if you wanted to write SQL on SQL Server or Oracle or MySQL, little changes will be there, but you can write same kind of SQL. In NoSQL databases, it is having different kind of types, document, key value, tabular, and graph. So different kind of syntax and languages will be there. Actual development started with 1970 about SQL databases, and this NoSQL databases started development around 2000. Examples for SQL databases are Oracle, MS SQL, DB2, lots more. Sybase is there. In NoSQL databases, you can see here MongoDB, Cassandra, HBase, Neo4j. Schema. If we talk about a schema, SQL databases are having fixed schema. Once you have designed your schema, it will be quite difficult for you to change. NoSQL databases provides a dynamic schema, so it can quickly change, and you don't have to worry about your schema at all here. Scaling, this supports vertical scaling. I have explained what is vertical scaling. If you wanted to increase performance, you have to increase CPU, RAM, and so on. NoSQL databases supports horizontal scaling. It means that if you wanted to increase more processing power and more storage, just you need to add more and more machine. Here, development model in SQL databases or RDBMS databases is mixed. Few of them are open source and few of them are commercial. NoSQL databases most of them databases are open source here. If we talk about the consistency, SQL databases or RDBMS databases follows ACID property, and NoSQL databases follows here base property. So there is a question from Paul. Does MongoDB have concept of stored procedures? No, Paul, it's not there. But there is something called server-side scripting. You can use JavaScript and you can, club your activity in a program, I can say, or in a script. Also, you can see here the kind of data and volume of data is increasing exponentially. So if we start from 2000 to 2011, structured data was more than unstructured data, but after 2000, it increased exponentially. So nowadays, most of the data are in the form of semi-structured, honest, or unstructured. So again, that's the reason NoSQL databases are more popular nowadays, because we have unstructured data, semi-structured data, and to handle and manage, we need to have NoSQL databases. Let's take example of data modeling in RDBMS. So just I'm trying to compare here RDBMS and MongoDB data model. So for example, let's say there is a client who wanted to design his blog website with some features. So what could be the difference in RDBMS and MongoDB schema design? What all features is there? Every post has the unique title, description, and URL. Every post can have one or more tags. Every post has the name of its publisher and total number of likes, and some more. So basically it is related with blog and posts. So in RDBMS, you should have minimum 3 tables to accomplish that task. All right. Now you wanted to retrieve data, so at least you need to join these 2 tables to fetch out this data, information, meaningful information, right? So, and you know that join is quite expensive. So how do we handle in MongoDB? So in MongoDB there is something called embedding documents. Okay. So what will happen is everything, all these 3 things you can club in a single document. Here you could see there is a way to perform it. So once you will learn data modeling, or schema designing in MongoDB, then you can understand well. So you can club everything in a single document, and while fetching, you don't have to perform join. Quickly you can retrieve information in a single query, and that's how you increase your performance of MongoDB. Here you could see another example. Let's say this is HR schema. HR schema in the sense human resource schema, where HR department manages information related with employee, department, location, countries, region, job, and job history. So in RDBMS, you would have seen, while learning RDBMS or in HR, if you have exposure to HR management database, so you could see this kind of tables will be there to perform all your activities in RDBMS. So here you could see 2, 2, 4, and 3, 7 tables. And if you wanted to retrieve complete information out of this, you have to join these tables, right? So let's say if we have to design in MongoDB, what you can do. Let me show you here. So here it is, let's understand this is for employee table, this is for department, this is for location, same thing, right? Now if we want to design this in MongoDB, in a very simple way we can club everything here in a single document here, and you can write all information in a single document. There is no need of writing 6 tables, 7 tables here. Here that is another way. So till here you could see employee, this is unique ID which I have given, name I have written, email ID I have written, phone number, job details, salary, departments, location, everything I have clubbed into a single document. So that's the benefit of MongoDB here. You can write everything in a single document. There is a question from Rakesh, how queries are performed in MongoDB. So queries are performed, there are various ways to perform the query, but still I didn't get your question. Okay, where to use MongoDB? This is again a very beautiful question here. So wherever we are using RDBMS for web application, we can use MongoDB there. For content management system, we can use MongoDB. For real-time analytics and high-speed logging, where you write your data to database, you can use your MongoDB. For caching and high scalability, you can use. For media, gaming, you can use. So if we talk about content management, this provides very beautiful features to add it. So there is a question from Reshma. How easy do you think will it be in deploy it is in existing system? If I say about my personal experience, Reshma, this is very simple to deploy anywhere. All right. So these are some use cases where MongoDB is being used. MetLife is using eBay, MTV, Sourceforce, Craigslist, ADP. So all are using for different kind of use cases. CNN, Foursquare, Justin TV, iVivo, various clients are there who are using MongoDB. There are some industries where we can use MongoDB. In financial services, you can use for order capture, time series data, risk analytics and reporting. In government, it is being used for crime data management, surveillance data, program data management, health record management. In health care, we can use for 360-degree patient view. Media and entertainment, we can use for content management. Retail, we can use. So let me explain here one example in retail. There is something called digital coupons. So we can build a very good project or product, I can say, on MongoDB for digital coupons. So what happens nowadays, people used to receive in message or email product coupons with some barcode and so on, so they don't have to take hard copy or print out of that. Directly they can go to any merchandise and then they can encash those coupons. So those kind of use cases where you can use your MongoDB. Now, if you talk about popularity of MongoDB in the industry, this is a comparison, with Google search volume of MongoDB in 2009 and 2013. You could see here MongoDB is having higher value. You could see here. Another example is dbengine.com. Let me show you this right away. So if we talk about this DB engine, MongoDB comes on 5th position across all databases. Here you could see. So this is the MongoDB, which is on the top position, top 5th position. So Oracle, MySQL, MS SQL, PostgreSQL, and then MongoDB is coming. Now, if you talk about just document stores database, so it is on top. You could see here. It is on top position, MongoDB. So this is about popularity of MongoDB. If we talk about the job trend, you could see here, from Jan 10 to Jan 13. It is having more job opportunity than any other NoSQL databases. Here is another example which shows from Jan 9 to Jan 14 here. Again, MongoDB is on top. So these are results from Indeed.com. Here is the link which has been given here. Where we should not use MongoDB. So again, this is a very, very important question. So wherever you need highly transactional applications, where applications with traditional databases system requirement like constraints like foreign key constraints, where you need native joins and so on. Any questions here, guys? All right, so there is question. Okay, Rakesh is having question. in RDBMS we use SQL to perform queries, but in MongoDB how do we queries? So there is different way to perform queries, Rakesh. The syntax, everything is completely different than RDBMS. But it is very, very simple. Object-oriented concept will be there, like db dot table name dot find. So it will search. It will work like select statement. So there is another question from Bala Subramanian. MongoDB is easy or difficult? So this is very, very easy, and anyone can easily understand this. Sarfraz is having question, can we use MongoDB with spatial data for SDO geometry? What is that SDO geometry? I didn't get that. Okay, XY coordinate. Yes, you can use that, and this is very, very, MongoDB is having very good functionality for geospatial data. So you can use it. Okay, a good question from Paul. Does it cache previously run queries? Yes, it cache in RAM. Okay, there is question from Rakesh. Can I use MongoDB if I am developing an application in Java? Yes, it is having very good combination with Java. You can use it. So let me ask one question. This is, by the way, a very good question. As I said, we can use MongoDB at the place of RDBMS. So can anyone answer why we should use MongoDB at the place of RDBMS? Anyone who can answer that? Yeah, Paul. Paul is asking, is there any prize? Yes, prize is there, Paul. Secret prize. Great. Kamal Raj is saying for high volume transactions. A fantastic answer. Vimal is saying which is having better prospect, MongoDB admin or developers. Okay, Vimal is asking question which is having better prospect, MongoDB admin or developer. Both are having similar demand. Okay, Senthil Kumar is saying for horizontal scaling. Great. So we got it. We got 2 points here. First one was for high volume transactions, and second is for horizontal scaling. Okay, Bala Subramaniam is saying become widely accepted for many types of application. Yes, that is also a very good point. Another point is we don't have to perform joins for polynomial data or hierarchical data. This is very, very important point. And then the speed will be very good. All right, guys, so that's all. Any other questions? Yeah, faster retrieval. You are right, Reshma. Any other questions? Yeah. All right, so that's all, and probably support team will share this slide to all of you. So thanks a lot, Babu. Thanks a lot, Balasubramaniam. Thank you, Kamal Raj. Thanks, Leela. Thanks, Paul. Thank you, Parvila. Thanks, Prabhu. Thank you, Rajendra. Thanks, Rakesh. Thank you, Reshma. Thanks, Sarfaraj. Thank you, Senthil. Thanks a lot, Shankar. Thank you, Vimal.